So my name is Tim Etheridge and I'm a senior lecturer at the University of Exeter. So what you're seeing is the preparation for our molecular muscle experiment that's due to launch at the Kennedy Space Center this November. So what we're doing is taking larval stage worms and putting them into a liquid bacterial feed and loading those worms into a gas permeable plastic bag. Now the gas permeable bit's really important because it allows oxygen and carbon dioxide exchange, so the worms can essentially breathe so they don't die of oxygen. And we are then sealing those bags closed to keep all the liquid nice and tightly in, and then putting those bags into a container ready for flight. So the aim of the molecular muscle experiment is to provide the first precise understanding of what the molecular causes of muscle loss in space are. We're, as a team, interested in what regulates muscle mass per se. For example, just maintenance in response to exercise, but also things in a disease perspective, like as we get older, we lose muscle. And so as a team, we're interested in understanding why that muscle loss occurs. And our spaceflight program is part of that general interest in why muscle mass changes in response to external stimuli. And spaceflight is one of those situations where muscle mass is lost. And so this experiment addresses that goal of understanding why muscle mass goes in space. Worms are, perhaps surprisingly, a very good model for human muscle maintenance. At the molecular level, both structurally and metabolically, they're highly similar to that of humans. And from a spaceflight specific perspective, they provide a lot of practical advantages, such as being very small, quick to grow, cheap, easy to maintain, relatively speaking. And so they provide a lot of practical advantages that are within the constraints of spaceflight work that make them good to work with. The primary reason we do this is to understand why muscle loss occurs in space. However, there's a train of thought that's generally accepted that spaceflight represents an accelerated model of the human aging condition. And so hopefully by understanding the molecular causes and countermeasures against that changes in spaceflight may provide an opportunity to understand human aging on Earth.